Alright. We should be live now. It does say live on the screen, so we're gonna go like we're live this time, just like we did last time. But I think we're actually live this time. Uh, so yeah, it's kind of funny. I've been in and around this trade for like 11 years. And apparently, there is a whole Facebook page called IBW Local 479 Apprenticeship. I just found out about it. I don't know who this email goes to. Like, I don't know anything about this. Like, like most of the information's correct. And I've just been like going through here. It's not a very active page, but like I've just been going through here and like looking at stuff. Like there's people asking like, "Hey, how do I get more information?" And it's just fucking silence. So I'm not sure what the hell's going on here. Uh, but yeah. All right. So let's. I will go through the first lesson. I kind of went through the first lesson in great detail and. Are we are we not getting it? Oh, I didn't post the link. I'll post the link. Some people don't know how to get here. Some people don't know how to get here without me posting the link. So, I give them a second. I hadn't really covered anything yet, so let's go to reports. So I'm going to cover the big points that I did on the last quiz. Just real quick, because we're going to go through it again. This first quiz was like a umbrella quiz that covered a lot of stuff. This one will. Uh, this one's just going to be about resistance and current, but you kind of have to know it all before you can do any of it. All right, what value remains the same? So current stays the same at all points in a series circuit. I'm going to repeat that so much for the next 2 years. Y'all are going to hate it. Uh, I mean, y'all won't get to hear it until next year. But uh, what value remains the same at all points? That is current flow. You only need two of the possible values. Let's pull up our thing. So if you look at, and I hope y'all can see the numbers. If you look at the formulas, these are four formulas. If you have any two values, you can find a third value. And then you have three values. And once you have three values, you can use any of these formulas. And there is a formula that interacts with any two values. The hardest one to make interact is power and resistance because they are so far away from each other, and that's a little bit confusing of a way to say it. But suffice to say, power and resistance don't interact as easily. We're generally not going to use the. That's not what I wanted. Let's try that again. Hey, there we go. We're generally not going to use these circles as they are. I much prefer using a what I call the chart. So that is writing the values down in this order. So RIEP. And the way the formulas work out in here is, let me change colors just to make it a little bit nicer. If you're going, oh, change the wrong color. Where are we? There we are. If you're going this direction, you multiply to get the next row. So R times I will give you E. So let's do R times I equals E. I times E will give you P. So R times I gives you E, I times E gives you P. So if you're going in from left to right, you're going to multiply. Now, if you're going this direction, you divide. So P divided by E gives you I. E divided by I gives you R. And this is all supported by these formulas. This is just another way to write the formulas, and it is my preferred method. Because you come in and you put, this is R total, I total, E total, and P total, and then you just make rows for all of your values in the circuit. So R1, R2, R3, that's I of R1, I of R2, I of R3, E of R1, E of R2, E of R3, and then, you know. So, and then now that you've got all the rows, moving up and down the rows is very easy. In a series circuit, let me just erase this. It's in my way. In a series circuit, resistance, and this will help you all day. I hope everybody's watching. Resistance will add up to the total. So 1, 2, and 3 will add up to your total. Current is the same throughout the circuit. Voltage adds up to the total, and power adds up to the total. And then, just like anytime things add up, if you had the total, and we'll see this in a couple questions, if you have the total and you're missing one of them, you just subtract what you have from the total to figure out what you need to get to that total. All right. So let me just click through these questions. That's what I just said. You have to disconnect power, or you can damage the meter. Series circuits only have one path. Voltage in series adds together. Algebraically, that's a. We'll get to that in the next lesson. Uh, Larger resistors drop more voltage than smaller resistors. Alright, let's go to the current results. Because I've got like 5 minutes before the next quiz. The resistance of the connecting wires. So it's usually negligible, the resistance of the connecting wires. Sometimes you will have to deal with it. But resistance of the connecting wires in series is generally less than the resistance of the load. When resistors are connected in series, their values are added to the total circuit resistance. So, like I showed in the pictures, you add up your individual resistance values to your total. Using Ohm's law was the equation for total resistance when the total voltage and total current are known. That will be, okay, voltage and current are known. So if you have I and E, how do you get R? So let's change to green. You have I and E. So let's say you have 5 and 10. All right. You have 5 and 10. How do you get R? Well, like I said earlier, if you're going this direction, you divide. And what we want is over here. So 10 divided by 5 will give you 2, right? 10 divided by 5? Yeah. Will give you 2. So, is E divided by I. This question took forever to type in. That's why you won't get very many more questions with formulas in them, because they're a pain in the ass. Alright, okay. Zooming really helps on this one. Alright. 12 volts was the total resistance of this circuit. So, this one's pretty easy. 12 plus 16 plus 8 plus 11. Or 10. 10 plus 16. Not 12. Let's pull up. So we got 10 plus 16 plus 8 plus. That's 45. Let's hide the names. Protect the innocent. So 45. They just add up to the total. Next. Okay, we already covered that one. You do need to disconnect power before you take your resistance measurements. This circuit, if the total resistance is 120, what is R1? So this is that instance where, let's grab red again. You have an R4. And we have a total of, I'm using the eraser. You have the total of 120 ohms. And we have individuals of 10, 40, and 20. Okay, I put that in the wrong lines, but bear with me. So we have a total of 120, and we have 40, 50, 60, 70 showing. So all of these together is 70 ohms. Well, that means we have 50 ohms remaining to get to our total. So the answer is 50. Does that make sense for everybody? I saw some people obviously say, I need help. So hopefully that made sense. It's just a addition problem. Solve for the resistance of resistor R1 in the circuit. So 220 divided by 5 is going to be R1. So it should be 44. Good job, most everybody. So let's clear this out a little bit. So we got 220 volts and 5 amps. So 220 divided by 5 gives us our 44 ohms. I'm going to pick up the pace a little bit. I know it's after 11. I always start getting messages from the people who aren't in the stream at 11, like, I don't see the new one. I don't see the new one. Are you not putting up a new one? Subscripts allow us to communicate precisely about various components. Yeah, so what we're talking about in this one, you all got it right. I won't talk about it. Yes. Current has to flow through everything in the whole circuit, so there's no way for it to go anywhere else. So if it starts out, it has to finish. Fuses and circuit breakers are connected in parallel with the load and all other components in the circuit. So fuses and circuit breakers are connected in series so that the current has to flow through them. If they were connected in parallel, even if they tripped, the current wouldn't stop because they can just flow around. The current in a series circuit becomes smaller. It does not. It stays the same because current stays the same through all the points of the series circuit. Solve for total current. So, this is something I neglected. So, if you are skipping, let's see. So if you are going this direction, you can skip a row to get the one that you skipped. So, how do you go forward? So in this case, you can go, let's just redo it. All right, let's get back in this. So you can go from E divided by R to get I. Or you can go from P divided by I to get E. So you can take a column, you can take a value and divide it by either of the two values to its left to get the other value to its left. So P divided by I gives you E. just like what is up in this top. Or E divided by R gives you I. So in this case, we're doing E divided by R to get I. What are our numbers? Because I've forgotten. 30 and 60. Well, that's 0.5. Somebody came out with 1800. Alright, so that finishes that. We're only 5 minutes behind. Hey, Antonio made it. Good. So let's launch lessons 3 and 4. Now, before we come back, you need to go to the school and pick up your test. It wouldn't be a bad idea to have the test out while we're going over some stuff. Just saying. I have looked at the test, so if you ask me a question directly from the test, I will know. Probably. But yeah. So there is a new quiz up. And it is lunchtime, so you guys have a good lunch. I will be back at 1:45 for the new stream. I'm gonna see how this works, cause I know you guys have to be there between 1 and 2. I know the stream gets posted, so if you get back if you don't get back till after 2, the stream will be up and you can watch that. So we'll see. Yeah. Good luck, everybody. Not finished that. In stream.